In this video, we'll look at a process for expanding numbers into simple continued fractions. We'll discuss the equations in the concept and we'll work an example. Let's get started. The process involves repeatedly breaking up numbers into integers and the remaining fractions. This equation represents what we are doing each time. Alpha k equals ak plus 1 over alpha k plus 1. Alpha k is the number we're breaking up into an integer and a fraction. Ak is the integer. It's the largest integer that is less than or equal to alpha k, and 1 over alpha k plus 1 is the remaining fraction. Alpha 0 is the number we are expanding, and it's also the first one we'll break into its integer and remaining fraction. Let's see how this works, but still using variables. We'll use the equation when k equals 0. Alpha 0 equals a0 plus 1 over alpha 1. But we know that alpha 1 equals a1 plus 1 over alpha 2. We can substitute this into the equation for alpha 0. So we have alpha 0 equals a0 plus 1 over a1 plus 1 over alpha 2. But we know that alpha 2 equals a2 plus 1 over alpha 3. We can substitute this into the equation for alpha 0. And now we have alpha 0 equals a0 plus 1 over a1 plus 1 over a2 plus 1 over alpha 3. You can see the simple continued fraction starting to form. We could keep going like this by breaking up alpha 3 into its integer and fraction parts, and then alpha 4, and so on. If the number we're expanding is rational, this process will end. We'll obtain a finite simple continued fraction. We'll see this in an example soon. But if the number we're expanding is irrational, then the process never ends. When irrational numbers are represented as simple continued fractions, they are infinite simple continued fractions. We'll see examples in other videos. As our example in this video, we'll expand a rational number, 170 over 39, into a simple continued fraction. We'll use a table to help keep track of the numbers and their integer parts and fraction parts during each step. The first column has the subscript k. The other columns have alpha k, ak, 1 over alpha k plus 1, and alpha k plus 1. Just so you're following, alpha k equals ak plus 1 over alpha k plus 1. These are the terms from this equation, just rewritten as column headings. Let's do the first row when k equals 0. Alpha 0 is the number we're expanding, 170 over 39. The largest integer that is less than or equal to 170 over 39 is 4. So a0 is 4, and the remaining fraction is 14 over 39. If we take the reciprocal of that fraction, we get 39 over 14. That's alpha k plus 1, in this case alpha 1. In the next row, k equals 1, and alpha 1 is 39 over 14, which is just copied from the end of the previous row. The largest integer that is less than or equal to 39 over 14 is 2. So we write 2 in the spot for a1. The remaining fraction is 11 over 14. That goes right here, and its reciprocal is 14 over 11. That is our alpha k plus 1, which is alpha 2 in this case. Just to make sure you're following, this equation and this one are the same. They are both for k equals 0. The one in the table has the numbers substituted for the variables. And these two equations are also the same. They are for k equals 1. And finally, the last column from each row is just copied into the first column in the next row. Can you do the next row? Hit pause and give it a try. K equals 2 and alpha 2 equals 14 over 11, which we got from the end of the previous row. The largest integer that is less than or equal to 14 over 11 is 1, so a2 is 1. The remaining fraction is 3 over 11, and the reciprocal of that is 11 thirds. In the next row, k equals 3 and alpha 3 is 11 thirds. The largest integer that is less than or equal to 11 thirds is 3, and the remaining fraction is 2 thirds. The reciprocal is 3 halves. In the next row, k equals 4, alpha 4 equals 3 halves, a4 is 1, and the remaining fraction is a half. Its reciprocal is 2. The next row will be the last one. K equals 5. Alpha 5 is 2, a5 is also 2, and the remaining fraction, 1 over alpha 6, is 0. Its reciprocal doesn't exist, so alpha 6 doesn't exist, and there isn't anything to bring into another next row. Row 5 completes the expansion. Now we can write the values of ak in the form of a simple continued fraction. 170 over 39 equals 4 plus 1 over 2 plus 1 over 1 plus 1 over 3 plus 1 over 1 plus 1 over 2. This 4 is this 4, This 2 is this 2, this 1 is this 1, and so on. We can also write it out like this so it fits on a single line. It's a nice shorthand. In this video, we looked at the equations and concept for expanding numbers into simple continued fractions, and we worked an example using a rational number. That's all for now.